4-5, we're looking at patterns in linear equations and graphs. First thing is intercepts. If you think of that word intercept, it'd be like if, a spy was trying to take information to the border and they were intercepted, it means they were
Caught.
They were grabbed, they were caught, something caught up with them. So when we talk about an x-intercept, we're talking about that's going to be where the graph hits the x-axis. Nice. So the x-intercept is going to be the x value where the line crosses the x-axis. It's where our line intercepts, where our line crosses, makes contact with the x-axis. So I'm just going to draw a random looking kind of line on there, something with a positive slope like that. And we don't really have a scale on the x-axis, so I'm just going to say this here is a negative 4 maybe. Maybe 3 and 4. You can do what you want for that. So the x-intercept then is going to be negative 4. That is the x-intercept. Now when we have that, what's the y value of that point right there? Go for it, Samuel.
What's the y value?
Yep.
6.
If we had to make a point, we could say the x value is going to be a negative 4 for that red dot. The y value has to be not 6, but go for it. 0. Do you agree that for any line to hit the x-axis, it has to have a height of 0?
Yes.
So that's what I want to put in here, that basically you're going to have some number, comma 0, and this number right there is going to be that x-intercept. Or you could say it's the x value when y equals 0. So I kind of said the same thing like 3 times there, but we okay for x-intercepts?
Yes.
But the actual x-intercept is not going to be some point. It's not the point negative 4, 0. The x-intercept is just the negative 4. Good?
Yes.
Y-intercept, same thing, but now we're talking about the which axis? Yes. So the y value where a line crosses the y-axis. For anything to cross the y-axis, the x value must be 0. So it's the y value when x equals 0. Or you're going to have the point will then be 0, comma, some number. And that number right there is going to be the y-intercept. And if you wanted to, you could put something on the graph, put in your little dot, and maybe say that's, I don't know, a 6 or something like that. We okay? Cool. If you were to look at a story problem, time is usually on which axis? Is time on the x-axis or time on the y-axis? Time's usually on the x-axis because x is going to be our independent axis, and things usually depend on time. Time is usually independent. So if you had something like, this is the amount of money in Mr. Falk's bank account, so it's hopefully going up, over time. Well, do you agree, numbers over here, to say I have a negative amount of time doesn't make a whole lot of sense, right?
Right.
So the y-intercept, if you have a graph that's something versus time, the y-intercept is going to be the starting amount. It's going to be what's the y value, how much money does Mr. Falk have when time, x-axis, is 0. Okay, so since time is on the x-axis, the y-intercept is often the, I'm going to say starting amount. The starting amount, because it's the amount when time equals 0. Some books, instead of starting amount, they'll say it's the initial condition. It's the initial, the starting condition is what you have at the starting. So starting amount, or maybe I'll write it. You don't have to, but it's the initial condition. How are we doing on A and B? You guys feeling okay for those?
Yeah, I'm not sure.
Okay.
Yeah, that makes sense.
Then if we jump to page 2,
Page 2 of notes in 5 million days.
without the chatter. So
I have
find
one.
3 points and graph. So for finding 3 points and graphing, I'm going to first write an equation. So I'm saying you start with $3 in a savings account, and every week you add $2. Every week you add $2. So if x is going to be my number of weeks, I'm going to do y equals a little space and then an x. If x is my number of weeks, after 1 week I add $2, right? After 2 weeks you add $4. After 3 weeks you add?
6.
So what goes in front of my x? Yep, that it's going to be a 2x or y equals 2 times x. You could put in the multiplication dot if you wanted to. But y equals 2x, because every time x goes up 1, your number goes up 2 more. And then plus 3. So if we were to go through and find 3 points in graph, what's the number we should put in for x? Anyone?
1.
1, sure. So if I put in a 1 for x, I'm going to put my 1 right in there. And 2 times 1 is 2, plus 3? 5. So after 1 week, I have $5. And it's not going to work real well on the type of graph I gave you, but something like that. If we would pick like a 0, now I'm going to take and put my 0 in for x. 2 times 0 is?
0.
Plus 3?
3.
3. So I have the point 0, 3. That's going to be my y-intercept, my starting amount. Started with $3. And if we do 3 weeks, it won't be on the graph anymore, I don't think. But if we do 2 weeks, 2 times 2 is?
4.
4 plus 3? 7. So over 2 up 7 gets me right there. So I could take my graph now and put a straight edge on there. Try to find something straightish. If you have something close by you can use. So I have that. Does that graph make sense for this problem? Yes. But does all of it make sense for this problem? If I have this graph fits the equation, but this part of the graph in red, does that make sense for our story problem? No, it doesn't make sense to say, 1 week before Mr. Falk started, he had $1 in the bank. 2 weeks before Mr. Falk started, he had negative $1 in the bank. 3 weeks before he started, he had negative $3. So the blue stuff fits the story problem, the red stuff doesn't. So the point is really just supposed to be, if you have an equation like this here, you can get a line that fits that equation, but sometimes they won't fit the story problem. So if this were the story problem, you would just graph the part in blue. This part in red, you would just kind of leave that off. Make sense? It's kind of like you have what they call limited domain, but you'll learn that later on in life. But only some numbers work for x. Time could only be positive. All right, last 2 graphs. If I were to put it on 1 for x, negative 2/3 times 1 is negative 2/3, right? I'm going to get some decimal answer. And graphing decimals is kind of a pain. We could go through and say, okay, when x is 1, it's going to have a height of 3 1/3. So that's going to be right about here. 1, 2, 3 1/3. And I probably lost you on the math. I wouldn't worry about it, but that's kind of a pain to graph, like the 1/3. So I would recommend this. What number could we put in for x that makes my fraction just become a normal whole number or integer? Not an even. Well, some evens would work, but do you think you know?
1/3.
Ooh, 1/3 I think is going to make it even nastier. That'd be like negative 2/9. So go for it, Luke.
Either 0 or 3 over -2.
Nice. If you do a 0 or, 3 over -2 would work too. I'm going to just do this. If I put in we could do 0. Why not? Because negative 2/3 times 0 is 0. So then we just end up with 0 plus 4 or 4. So 0 is nice. And we get the point over 0 up 4. You guys okay with that being our dot in the graph for over 0 up 4? Another one that would work, because we have something divided by 3, what's the inverse of dividing by 3?
Multiply.
So if I make 3 my x value, if I put a 3 in there, I end up just with a negative 2. Negative 2 plus 4
2.
is 2. Maybe 2 ways to look at that real fast. I have negative 2/3 times 3 plus 4. One way to look at it is to say, this 3 cancels with this 3, and I just get the negative 2. The other way to look at it is kind of like this here. When I multiply those fractions together, negative 2 times 3 is negative 6. Negative 6 divided by 3? Negative 2, which then I just have my plus 4. So you could kind of combine the numerators. Negative 2 times 3 is negative 6. Combine the denominators, you get a 3 down below, and then just do the division. Work for you? So for my last x value, you could put in a -3, or you could put in a 6, or a -6. But I do multiples of 3. So should we just do a 6?
Yeah.
So I'd look at it as though I have my 6 right here. -2 times 6 is -12. -12 divided by 3 is -4. 12 divided by 3 is 4. So -4 plus 4 is 0. So now I have my x-intercept. Oh, I forgot to do my 3, 2. So 3, 2 is over 3 up 2. So right there's my dot. And then I do 6, 0. So I start at the origin. I go 6 to the right and up 0. So that's going to be my last dot. Then I could take and put a straight edge on there. Or free-handed if you want. But we get a line like this here. Good? Very last one. Similar but different.
Okay.
If I put in a 0, I'm going to get a what for y? 1. If I put in a 3, I get a... It'll be a negative. Negative 1. And if you're taking a little longer, don't worry about it. 6 is going to give me a... be a -12 divided by 3, so -4 plus 1, -3. So if you're a little slower, that's fine. You could take and punch them in a calculator too, especially if you're using your fraction key. So I have over 0, up 1. So my first point, 0, 1, is over 0, up 1. Then I have my 3 negative ones, so I start the origin, go 3 to the right, down 1, so right there. And now for my last point, I have 6, -3. So I start at my origin. I go 1, 2, 3, 4, 5, 6. Then down 3. So right there is going to be my dot. And now I can put my line through there. What do you notice about example 2's graph and example 3's graph?
They're the same. Except sort of the same.
By same, you mean their slope is the same. And if their slope is the same, that means they are parallel. Do I have that at the top of page 3? Nope, looks like I don't. So I'm going to say parallel lines. So parallel lines have the same slope. Does anybody know what the slope is without having to figure it out? Think back to the calculator thing we were doing. Go for it, Samuel. Perfect. Remember that calculator thing we were doing said the slope is this number here in front of x? So if you go back and remember, both of these have to have a slope of -2/3. And you could find that, look for points. This point, you go down 2, you go 3 to the right. They both have a slope of -2/3. And this number here, the +4, is the y-intercept. Because if you put in a 0, this drops out, so y just is going to equal that number. The y-intercept of this one has to be a 1, because that's a 1. So it all ties together.
Okay, so
And
how
we're done.
should we